Hello everybody and welcome back to the multiplayer project where I'm gonna be honest, this one took longer than I expected. It is currently 2:40 p.m. and I've been working on this for about 4 hours today, but it won't take anywhere near that long to implement, I hope, or rather to re-implement. But I did have to delay chat and seeing our motion from GameStay updates to next episode. So that's gonna be a thing, just so everyone's aware. This requires significant work in both the client and the server today, and it's gonna be maybe a bit extensive. So first things first, let's hop into the server here, and let me just pull open the sandbox as well. This is the wrong sandbox. There we go, this is the correct sandbox. And we are going to need to create ourselves a new item. This will be a new class in our game code. In fact, we're gonna need two. The first thing that we're going to do is game enums. And this is, we don't need any of these usings. This is just going to be a holder. This music is a little loud. I mean, I like it, Europa. Good exuberance, but maybe a little much. There we go. So this is essentially going to be exactly the same as our comms enums, except we're going to go into command here, and we're just going to copy in our command types. Like so. Now I also want to put in a couple of, like with our comms enums, I want to put in a reference for what each of these commands is intended to look like. So this first one here will do command. This is going to be passing in 0, channel, message. Excellent. This one here is going to be something along the lines of command 1, and then also it's going to be taking in parentheses, position X, position Y, position Z. Like that. And this is going to be the case for move, and then for use, we're going to be passing something along the lines of command 2, and that is going to be item ID, or it could also be command 2, and it would pass in ability ID. We need a way to differentiate between that, but we'll have that. That's not a problem. So we are going to then do interact here. This is going to be command, this is going to be 3, and this is going to be entity ID. Excellent. And we're not going to be implementing most of these today. We're just going to be getting our infrastructure for commands on the server side done, as well as responding and having things happen. So the next thing that we're going to do is our join channel, and that is going to be command 4 and channel. And then for leave channel, we're going to have command 5 channel. Excellent. For invite, we would have command 6 and channel. Or not channel. Command 6 and player. And then for leave party, this would just be basically a header only command. Command 7. We don't need anything for that. Okay, so that tells us what our commands are going to be. Now, you may notice that we've got an entity ID here. That's the other C# script that we're going to have to create here. This is going to be a class, and this is going to be entity.cs. Excellent. Now, inside of entity, we're going to need a fair number of things. We are not going to need using system or using system.collections.generic. But we are going to be using system.numerics, which is going to give us access to quaternions and vector 3s, although we're going to be representing everything, at least for now, in vector 3s, because that's easier to deal with. We'll also make this a public class entity, but for now, we'll leave that mostly empty. And let's hop into our server code here, because there are a couple of things that we need to do. First off, I'm going to go ahead and that's our CMD message. We're going to need that. I'm going to go ahead and minimize most of these processings, and most of them are already minimized. We're also not interested in the initialization or in message sending for right now. But in the process CEW message, we are going to need a couple new things. Specifically, when we log in, we're going to need to say client session.entity, and actually this should be lowercase, .entity equals new entity message. Of course, this constructor doesn't exist and client session doesn't have an entity. So let's give client session an entity. This will be public entity. And of course, I automatically put in using channel MMO server.gamecode. Wonderful. And then we'll hop back to the entity here because we need to put in a region constructors, and we'll end that region. Excellent. And we're going to need a public entity, and we will just take in a string entity name. Excellent. So when we have this, we are going to then get ourselves a region public fields, and we'll end that region. And what all fields will we need for our entity? Well, we will probably need to expand this later, but for now we'll do a public string name. We will do a public float movement speed, and we'll set that for now equal to 1.0f. Excellent. We'll do a public vector3 position. We'll also do a public vector3 rotation and a public vector3 scale. And these vector3s come from system.numerics, not from Unity, but they work almost exactly the same way, so that's nice. We don't have to create our own vector3 class. We'll also do a public vector3 desired position. Excellent. And now we will create our first property. We will need a, if I can get the correct character here, we'll need a region properties. We'll end that region. Inside of this, we'll do a public vector3 desired direction. And we're just going to do a private set. We don't want this to ever be settable. That would be completely useless. But we will be able to get it here. And that is going to be return desired position minus position divided by desired position minus position dot length. And that's just some vector math here, and length actually in this library is a method, not a property. So that's just some vector math to get us the direction that we want to go towards the desired position. We don't know what the desired position is yet, of course, but let's go ahead and set this up in the constructor so that we can actually have this somewhat doing what we want. But first we're going to do pathfinding, because of course we don't necessarily want it to just walk straight towards the position the player wants to be at. We want it to avoid obstacles on the way. But for now, we're just going to walk straight there. We're also going to need one more field, though, so let's go ahead and do that. We're going to create a new region here, and this is going to be const fields, and we'll end that region. Now, we may not want to do this as a const for now, but we know for a fact, theoretically, that every game tick is roughly 100 milliseconds, right? It may be plus or minus a little bit depending on how long it takes to calculate the tick. But we know that it's roughly that. So we're going to do a private const float delta time is equal to 1f divided by game manager dot game underscore speed. And that, of course, means that we need to go into Game Manager and set our game speed from private to public. Excellent. So now this compiler error should go away. And then when we are creating our entity down here, we are going to not use that, but we're going to set the name equal to entity name. Why do I have to do pathfinding here? This happens later. We'll call that a preview. We need to do name equals entity name, position equals vector3 dot 0, works exactly like in Unity, where it sets that to just to a empty vector3. Well, not empty, but all the numbers are initialized at 0. And then we'll do rotation is also equal to vector3 dot 0. Again, we may want to switch this to a quaternion later on. We probably will want to. We'll also do scale equals vector3 dot 0. And vector3 works off of floating points as well in this library, so that's absolutely perfect for us. And we'll also do desired position equals vector3 dot 0. Excellent. So that gets us our constructor there. Perfect. As well as all of the fields that we're going to need for the entity. So let's hop back into the server here. We're creating ourselves a new entity there, and we need to set that entity up to do a couple of things. We're already assigning it to the client session, which is fine, but we also need to, at this point, grab the instance reference that we're returning here. So we'll say instance new instance equals GameManager.createInstance, blah, blah, blah. And we want to then add this in. So we'll say new instance dot entities, which does not yet exist, dot add, and we'll add in client session dot entity. Excellent. Now I'll hop over into the instance code here, and we will go ahead and put in a public list entity of entities equals a new list of entity, of course. There we go. Excellent. Now we're going to have to change this get state update, and as well as the tick, but we'll do that in just a little bit here, because first we need to set ourselves up a new comms enum, and this is going to be CMR, and that is going to be command response if error. So this will only respond back to the client if the command that it receives is invalid in some way. So that will simply be a header reason. Wonderful. And now I believe all we need to do is we need to set up our process CMD message. So we'll hop over to the server here, and in our process, we're actually done with process CEW message for now, so we can minimize that. In our process CMD message here, we definitely don't want to debug this anymore. That is not amazingly useful, but this message is in the format command followed by command type, and then that's just an integer, right? And then that would be optionally beyond that, so we're going to use parentheses to indicate that it's optional. This would be then param1 onward, so on and so forth, and then a closing curly brace. So first thing we want to do is check to make sure that this is an actual command. So if message.substring 08 is equal to the following string, command, like that. If it's not equal to that, then we want to say, hey, wait a minute. This isn't a command at all. And we want to send, at this point, message types.cmr, and that'll be UC, and that'll be client session.address that we'll send that to. So the client doesn't know what to do with this receipt yet, but we'll tell it what to do later. But we'll then return because we errored out of that one. We need to do one more check though. If not client session.authenticated, so if the client session is not authenticated, or client session.logged-in character equals an empty string, and let's hop over into session and default this to be an empty string, or actually let's default this to be null. And instead of checking this to be an empty string, let's instead just check to see if it's null. That'll make it a little easier. Okay, so if that's not the case, then you need to be authenticated and logged in to send commands. So we'll just send message types.cmr, and that will be a UA error, and that will be sent to client session.address. And then we'll return. However, if it gets past both of those checks, then this is probably a command of some type, and we'll need to verify it. So let's remove that command header, message equals message.substring 8. So that'll remove the header and this initial curly brace. So we'll split off the header, and then we will also remove the trailing curly brace, closing curly brace. I didn't want this to be 3. There we go. We'll also say message equals message.trim, and we're going to trim off the closing curly brace. Excellent. And this is where I started getting really confused. Because at this point, here's the problem. For the move, we're going to be accepting a command, and that is going to be command type 1, and then it will have a parenthesis with some numbers inside. Like that. That's what we will be receiving. And I was like, okay, so we want to split this by commas. Wait. We want this, and then this. So I started getting really confused, and then I did some research and found that the best way to handle this is via regular expressions. So we are going to go ahead and use, what is it that it is called? System.text.regularExpressions is what it's called. Now, at this point, we're trimming this off, and we're trimming this off. So this is what our string looks like. And we want it to be split into these two components, or more if we have more parameters here. So this is going to be exciting. We're going to do an array of string components equals regex.split message, and we want this to be a literal string. We don't want it to interpret anything inside of this string. And this is going to be confusing. I don't pretend to understand exactly how this syntax works. Regular expressions are a bit of black magic to me. I found this on the internet. So this is a comma. This is an opening parenthesis. This is a sub-expression apparently. And then this is going to be question mark, exclamation mark, opening square brace, a caret, opening parenthesis, a closing square brace, asterisk, a backslash, closing parenthesis, and then another closing parenthesis. I'm pretty sure that's correct. Let me just copy the entire string literal over from my other project just to be sure. Okay, did that change anything? I believe it did not. So I believe that this is correct. I don't pretend to understand how this works, but I know what it does, and it splits by commas while ignoring commas that are within parentheses. I don't pretend to know how it works, I just know that it works. Okay. And I commented this as, oh boy, here we go. And I'm going to do the same thing here. So next we need to say, let's figure out what command type we're dealing with. So we will switch. And we will cast this over to command types. But we need to parse it out. So int.parse. But we now need, we have command type equals, right? So this is command type equals some number is the way that this is formatted. So we need to parse that out, and that is going to be components 0.split. We want to split this along the equals, like that. And then we want to take the first or rather, we want to take index 1 in that array is what we're comparing. Okay, that's the super complicated stuff out of the way, in theory. So we have several command types, right? So it's going to be case command types dot chat, and then we'll break out of that for now. It's then going to be case command types dot move, and we'll break out of that for now. Case command types dot use, which we're going to say to do. And also we're going to, in the chat, I did decide that our supported channels will be group, world, trade, LFG, guild, and whisper. At least for now. We may add more later, but otherwise, chat is to do. I was planning on doing chat this episode, but that didn't happen. In the netcode, though, I will go ahead and add a new class here while I'm thinking about it called the chat server. But we're just going to leave that empty. I don't believe I did anything with it. Yeah, I just left it completely empty. So that is perfect. And let me hop back over to the server here. Okay, so we then need to fill out the rest of these. So we need a case command types.interact. And we'll do to do and break out of that. We'll need a command types dot join channel, which we'll do to do. We'll need a command types dot leave channel, and we'll break. And then we'll need a command types dot invite, which we'll to do, and then break. And then a case command types dot leave party, which will also to do and break. Those are the commands that we're going to support for now. We will almost certainly add more later. But move is the one that we are interested in implementing here. So the first thing we need to do is say if components.length is not equal to 2, then we just want to break out of here. Because we have the, and actually I'm just going to put this in curly braces just to make it a little clean, not like that. A little cleaner. There we go. And then we'll say wrong parameter count for this command should return an IP error. And just to save us a little bit of typing, we'll put that IP error right at the end here. So we will do send message types.cmr, and that is going to be the type IP. Client session.address is who we're going to send it to. So anytime we exit this switch statement, it will send an invalid parameter. Wonderful. So then we need to do otherwise. If we have the correct number of parameters, then we need to check to see if we have the correct coordinates. So we will go ahead and say string coordinates equals components 1, which we know for a fact that this is the only parameter that we have at this point. So we have components 1, and we're going to trim off the leading and trailing braces, or the leading and trailing parentheses rather. So we're going to do something like that. And we're also going to do dot split, not slit, split on commas. Okay, so that'll get us an array of strings. It'll split off, or rather it'll trim off the parentheses in our vector 3, and then it'll split it according to the commas, so that'll give us, in theory, 3 coordinates. So if coordinates.length is not equal to 3, then we don't have enough coordinates. Send an error. Like so. There we go, and that'll just automatically send that invalid parameter error. While I'm thinking about it, I do want to change one thing in the chat box here. This default here, if we if we send it with an unrecognized command, I don't want to just send it as a chat. I want to instead say something along the lines of add chat message, and we are going to add in the message. Let me actually pull this open to see what exactly message I wrote previously, because it had a little bit of markup in it, and I just want to remember. Yeah, that's all it was. So it's just string.format, and then this is going to be color equals red to indicate that it's an error of some type, invalid command name, and then single quotes, and inside of those 0, and then we will pass in command. Excellent. This needs to be like that. Now that should work. Fantastic. So we're no longer sending invalid command types to the server. Instead, the client is just like, pass. Wonderful. Okay, so the server here, we now know that we have enough coordinates, but we don't necessarily know that they're integers, I suppose. But we're going to assume that they are for now. We're going to work later on making all of this more robust so that we don't crash when things go wrong, but for right now, we actually want to crash when things go wrong. So that is definitely something that we want to continue doing, because I want to be well aware when things go very, very wrong indeed. So down here, we're just going to say float x equals float.parse, and we're going to parse in coordinates 0. Excellent. Then we're going to say float y equals float.parse. We're going to do the same thing, coordinates 1. And then float z equals float.parse. And that's going to be coordinates 2. Excellent. And then all we'll need to do here is client session.entity.desiredPosition equals new vector3. And that will apparently automatically fill system.numerics here. We could also do using. For now, I guess this is fine. And we'll pass in x, y, and z, and then we will simply return. Excellent. And of course, this break is no longer reachable, so we'll just get rid of that. Okay. So that's all well and good, and we can set the desired position now, but we don't really do anything with that desired position. So let's hop over into our instance script here, and let's update our tick function, which is already being called. If entities.count equals 0, we should probably close this instance. But for right now, we'll just move on. And then we'll say for int I equals 0, I is less than entities.count, I++, entities I dot, if I can get over there, there we go, dot on tick, which doesn't exist. We'll hop into our entity here, and we will go ahead and implement that. Excellent. We're also going to need one more thing, so we need to implement 2 methods here. So we'll do public void on tick, and we're going to say to do pathfinding, as we did previously. Pathfinding. Close enough. Typing is hard. So when we tick it, all we're going to do right now is, if we're not at our desired position, we want to step towards the desired position at movement speed. So we'll just say if position is not equal to desired position, there we go, and desired position minus position dot length squared is greater than or equal to, we're going to do movement speed times delta time, And then we're also going to square that. So multiply that by itself, movement speed times delta time. And apparently I typed the wrong curly brace. Okay, so there we go. If our position is not equal to our desired position, and our squared length is greater than, or rather the squared distance between our position is greater than how much we move in one tick, then we will step towards it. And all we want to do there is position plus equals desired direction times movement speed times delta time. And the reason we're doing this squared is because square root calls are pretty slow if we're going to be doing a lot of these all the time, which the server absolutely will be. So we want to avoid square root calls whenever possible. Here, the desired direction, we have to normalize this, and so we can't really avoid this square root call, but we don't need to take a square root call here because we can just compare the squared numbers. So that's not a big deal. So one square root call per tick there is more than I would like, but I also need to remove this space because we're getting a compiler error there because that operator is incorrect. There's one more thing, of course, that we need to do here, and that is a public string to UDP message. Wonderful. And that's going to be string builder SB equals new string builder. Okay, and then we don't need curly braces. I don't know what I'm doing. We're going to do sb.append, and this is going to be entity name equals, it'll always start with the entity name, and then sb.append name, and then we're going to also append in a comma. There we go. And then we're going to do sb.append. This is going to be movement speed. Actually, we could combine these. Just have a comma there, get rid of this line, and then movement speed equals, and then sb.append movement speed .toString. I want to do this manually because I want to control how many digits it is. We don't care about any digits beyond the second decimal here. That's the precision that we're going with. And then we're going to need to append in another comma, so sb.append. This is going to be like this, and for right now we're just hard coding all of this. We'll also put in an sb.append closing curly brace before I forget, and then we will return sb.toString. Of course, we also need to send in all of these other things here: position, rotation, scale, desired position. There's another thing that we want to do, but we'll actually come back to that thought in the instance as we're updating that. So for now, we just want to do sb.append, and we're going to string.format, and this is going to simply be position equals, opening and closing parenthesis, 0, 1, and 2. And all we're going to pass in there is position.x.toString, and once again, we only care about 2 digits there. And then position.y.toString, same thing here. And then position.z.toString, still only care about the 2 digits. And that's to help save some bandwidth. We don't need precision higher than this. This is close enough. So we're going to just copy this at this point an additional 3 times. 1, 2, 3. There we go. And then instead of being position, this will be rotation. This one will be scale. And this one will be desired position. Excellent. And desired position is going to get a little long, so we're going to move position.z.toString over to there. But this will then, of course, be rotation.x.toString, and we'll need to just paste in rotation here and here. This will be scale, and we'll do the same thing. If I can get that selected, there we go. And this one will be desired position. we'll just paste that like that. Wonderful. So that will put in all of the information that we need for the UDP message. And then in the instance here, we are going to then also change our get state update, because we now have things to actually send. But first we're going to say to do partial updates, because we don't always need to change everything every message, right? So we would maybe only send a full message like every 100 messages or something like that, 1% of the time, and then otherwise just send things that are being updated. Something like that. But first, we're going to need to get ourselves a private string builder here. And in fact, we could make this a private static string builder, SB, equals new string builder. So this way, we only ever need the one string builder for every instance, and we don't create a new string builder every time we're getting a state update, which we're doing every instance 10 times a second. Let's not do that. So we're going to do sb.clear. And of course, this is going to be static, so this only happens once. We're also going to return sb.toString, just to get rid of that compiler error. So all we need to do here is construct a proper game state message. So that's going to be sb.append. This is going to be game state, and then instance ID equals, like that. And then we're going to do sb.append. We're then going to append in our instance ID. That's an integer, so that is absolutely fine. If entities.count are not equal to 0, then we're going to also do sb.append a comma. So we're not going to append this comma if we don't have any entities in the instance, but we will append the comma if we do. Then we just need to iterate through this and do for int I equals 0, I is less than entities.count, I++. And we are going to say sb.append entities I dot to UDP message, not string, dot to UDP message. If I can type, apparently, wow. That was pretty exciting. No typing skills whatsoever on display there. Of course, we also want to append a comma if this is not the final entity. So if I is less than entities.count minus 1, then we want to, at that point, completely mess up our curly braces. But there we go, they're now fixed. We then want to do sb.append, and we want to append in a comma. Then at the end, when we're done with everything, sb.append, and we want to put in a closing curly brace. Excellent. So that's our instances properly constructing there. Wonderful. Now our chat server we're not doing anything with, obviously. I'm just checking to make sure. I think that's all of our server-side stuff done for right now. So let's hop over to the client. If I'm wrong, then that, of course, means that we'll have to change it. But let's hop over to the client for right now. And while we are here, we are going to need to do a couple of things. First off, in the comms enums, we need to add in the CMR, and I'm just going to copy that in from the comms enums in the server, which is here. There we go. CMR. And we'll just copy that in like that. And now we need to handle receiving a CMR message. So let's do exactly that, shall we? So this is, of course, going to be this is literally going to be the same thing as basically everything else that we've done here. It's going to be a parse CMR message method, and this is going to be message types.cmr. Excellent. And then we're going to do a private void parse CMR message. And this is going to pass in string content. And inside of this, we can just say a command failed. Let's see why. So we're going to switch our content, because that's just going to be 2 letters that it's going to say there. So we'll have a couple of cases here. Case IP, and we'll break. Case UC, and we'll break out of that. Case UE, break. Case UA, and we'll break out of that as well. Okay, so those are our 4 cases there. I want to just make sure that in the server we're actually using those. So here, if we send the wrong coordinates, it's an IP. If we are, if it's not a command, then it sends unknown command. Excellent. Unauthorized, or simply, yeah, this would be unauthorized. And then the last one is unknown error, which we're not currently sending, although I think I did potentially a default. Let me check. I did not. Okay. So when we receive these, all we need to do is just copy this, except instead of uimanager.showModal, we're going to just log it in our log. So this is going to be game UI.chatbox.addChatMessage, like that. Of course, that requires some input, but let me just pull open the client code here that I had pre-prepared. There we go. And this is going to be color equals red, and this is going to be command failure, invalid parameter z, like so. Wonderful. And now we're just going to copy that and paste that here and here and here. But instead of invalid parameters, we are going to say unknown command. And actually, I'll put a period here as well. And instead of invalid parameters here, this one is unknown error. And we may actually want to do case UE default, like that. Excellent. So this one would then, instead of invalid parameters, be unauthorized action. Excellent. And then for our parse GMS message, all we're going to do is just debug.log that content. Okay, I feel like I'm forgetting a change that I made. But maybe I'm not. Maybe this will work, but it will probably be broken. Well, first off, this is a problem. Yeah, that's because this, for the add chat message here, this seems, or rather this needs to, when it defaults, it needs to, instead of break, it needs to return. That will solve that issue. Okay. So let's compile that. Wonderful. I also want to do one more thing here quick. And I want to go into our scripts here, and we're going to create a new folder, and that's called representation. Inside of that, we're not going to have a whole lot. We're going to create a C# script. This is going to be the representation manager. And this is what's going to represent in graphical form these messages that we're receiving. Inside of that, we're not going to do too much with this just now. All we're going to do is public game object entity prefab, and we are also going to do public list entity entities equals new list entity, and that's it there. And then we'll also create ourselves a new C# script, and we'll call that entity. And inside of entity, there is a fair amount of things that I've actually already done. We're not, strictly speaking, using this yet, though. But we'll just go ahead and go over it since I have this completed anyway. So all we need here is to be using system .text.regular expressions as well. We don't need any of this information. We will need public string entity name, public float movement speed, and we'll also need the public vector3 position, rotation, scale, and we'll also need public vector3 desired position. And then we'll do a public void from UDP message, string message, and this is going to be largely the reverse of the to UDP message, but this is not super complicated, I suppose. So all we need to do is say if message.substring 0 to 7 is not equal to entity, and then an opening curly brace, then we need to debug.log error received an entity update that's not valid. And then we'll return. This should not be void, this should be void. Excellent. And then we will do basically the same thing that we did on the server for getting the commands. So message equals message.substring. We're going to take off the header here, so that's just remove the header. And then we're going to say message equals, wanted a space there, message.trim. We're going to trim off the closing curly brace. Trim off the closing curly brace. And then we're going to iterate through the components, or rather we need to do the regex again. So string components, and actually I'm just going to literally copy this from the server just to make sure I get this exactly correct. So in the server here, when we are parsing this, we're just going to copy this. It's going to be literally the same thing. So we're going to paste that there. Wonderful. And then for int I equals 0, I is less than components.length I++. We will say string array com equals components I dot split, and we're going to split that on the equal sign. And we're also going to declare an array of strings coordinates, and we'll reutilize that later, or we'll utilize that rather later a little bit. So for now, we need to switch com 0. And currently this can be 6 things, right? It can be case entity name, which we'll break out of. It can also be case movement speed. Wow, I cannot type. Movement speed. And I just want to verify that that's exactly what I called it, because I did not actually include movement speed on the previous one, but it absolutely should be included. Yeah, movement speed. Okay, so case, this should then be position. We'll break out of that. This should then be rotation. This should then be scale. And then this should be desired position. Now, this is stuff that I ran out of time for, and we are going to use more heavily a little bit later on, but we'll go ahead and finish this implementation here. Entity name is equivalent to com1 in that case. For movement speed, for movement speed, it would be movement speed equals, and then this would be float.parse com1. Excellent. And then for position, rotation, scale, and desired position, these are all going to be largely the same. Coordinates equals com1 dot trim. We're going to remove off the opening and closing parentheses. And then we're going to do dot split, and we're going to split that along commas. And then simply position.x equals float.parse coordinates 0. position.y equals float.parse, coordinates 1, and position.z equals float.parse, coordinates 2. And then transform.position for this one is also equal to position, because we want to just update this visually. Now we're going to copy all of this except for that transform.position update, and we'll do this. And then here we'll do transform.rotation equals... Actually, you know, we'll not do that, because we're probably going to swap this over to utilizing quaternions, right? So that's fine. We do want to make this be rotation.x here and here. And then for scale, we are going to also paste this in here, as well as here, really. And this would be scale.x. And then this would be desired position.x. Excellent. And then we can go ahead and set our scale here. So transform.scale. We'll go with local scale equals scale. Wonderful. Okay, so we're not really utilizing this just yet, but for now, that should do the trick. So let's hop over to our net manager here. We're already receiving CMRs. We're sending out our GMS messages. I think this is good. Let's test this and see what I forgot. I guarantee you I forgot something. Actually, I know what I forgot right now. We need a empty object here, and this would be the representation manager. We'll place that right at the top, and we'll just call this 000. We'll add in a representation manager object, and then we'll create ourselves a 3D object cylinder. No, capsule. We'll create a capsule. And we will call this entity. And we'll slap on the entity script. Wonderful. And we'll just drag that in here. That's now a prefab. Fantastic. In the representation manager, we'll hook that up. It's not like we use that yet, but we will in a little while. So let's go ahead and fire up the server here. Hopefully that doesn't have any compiler errors. It does not. Okay, we'll run the client now, and we'll see if this works. So we should be able to log in here once our encryption handshake finishes anyway. There we go. We'll log into ASDF, and you can see here we're receiving these currently. So let's do /test. This should just give us red text. Okay, it flashed white first, and then it was red, but that's fine. Ah, now you can see here that this did not close. That is an issue that I fixed that we will fix in just a moment, but first I want to test this. /move, we're going to move to 1, 2, 3. So we should see that this desired position changes to 1.00, 2.00, and 3.00. We should also see that our position here starts actually moving on the server. It's moving? Yeah, that works perfectly. Now, we don't move very quickly. There's no doubt about that. No doubt about that at all. We're halfway there right now. Glorious. We're 2/3 of the way there. 3/4. And we should be arriving quite soon. And there we are. We have arrived and we have stopped. Wonderful. So we can use this information to update our visuals on screen. So that is ideal. Now, as I said, we do need to fix one little thing, and that was in our MMO here in the chat box. This here, when we return, we now, of course, need to do on-end chat input, because we aren't doing that anymore. So let's just do on-end chat input there. Wonderful. So now we can log into our character, and issue a command to the server saying, hey, we want to move here. And the server will start moving us there, and it'll tell us where we want to move, and it'll also tell us where we currently are. And we can use that to display our current location on the screen and interpolate between server updates, which are only coming in at 10 FPS. So that is very good. Let's hop over to our to-dos here. And it's in here somewhere. Here it is. So entities and server command parsing is now in. We have the difficult parts done there, and we can add in more commands whenever we need to. So next up is the delayed features from this episode, which is going to be chat and seeing our motion from game state updates. And then after that, it's going to be, of course, client input to command interpretation. And by that I mean, currently we can only send commands through the chat system, right? That's going to change, because we're going to want to be able to input commands a little bit more intuitively. So that is what we will be doing next episode. Until then, though, you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.